Now, can you recall me that what are all discrete random variables that we have studied? What was the first one, second one, third one, and fourth one? I think we have studied Bernoulli. Yes. We have studied binomial. We have studied Poisson. We have studied, last one was uniform. Okay. Now let's just see the continuous random variables. So here we just have two, three. One is uniform. Second one is exponential, or I mean, I do not know whether this is the same order in which I will be having the slide, but that's okay. Exponential. Another one is normal distribution. So there are two, three distributions that we are going to study in the continuous also. Now, if you notice, this uniform is in discrete also, in the continuous also, but that is okay. So I will call here the discrete uniform. If you want, you can call discrete uniform. You can call the continuous uniform here. Okay. So this is the continuous random variable. Now, if I ask you, what is the difference between discrete? What is the discrete random variable and the continuous random variable? Can anyone tell me the difference? We have talked about the difference earlier. If a random variable x takes countably finite values, discrete values, no, it can take infinite values also. Yeah, you can say discrete values, something like this, countably finite values. Okay. So if the random variable is taking countably finite values, then it is a discrete random variable. For example, like we have seen some examples. Let's suppose that there is a classroom. In this classroom, there are students, right? I mean, we have seen many examples like rolling a dice and these things. But we started with this example. That let's suppose there is a classroom. In this classroom, there are a couple of students. If I'm mapping that to a grade, okay, then this G, which can have A, B, C, D. Let's suppose these. Then this G is a discrete random variable. But here, X will take uncountable values. Okay, which means, I mean, here it could be infinite, here also it could be infinite, but here, if in case of discrete, if it is infinite, then it is countable. And then in case of continuous, if it is infinite, it could be uncountable. If you're not familiar about countable and uncountable, let's not worry about it. Okay, you can understand in this way, very simplistic way, that discrete means finite values, continuous means infinite values. I mean, that's not very good definition, but if you're not good with the countable and uncountable sides, then you can just understand like this, that discrete means finite and continuous means infinite. So if you're mapping every student to maybe height, then this height could be anything. Maybe let's suppose this is from ranging 120 centimeter to, let's suppose like maybe 200 centimeter or something like this. Okay, so this height could be anything. So I can have any number in between this. Okay, maybe 120.00001 is also allowed. Any number in between this is allowed. Then I will say this h, let's suppose this h is a random variable, then it is a continuous random variable. In case of continuous, it takes infinite values, actually uncountable infinite values. Okay, so let's see one definition, which is probability density function. So earlier we used to have probability mass function. We do not have probability mass function here. So here we used to have probability mass function, but here we have probability density function. Let's just see what is this probability density function. So a random variable x has a PDF fx, which means probability density function. Then we can calculate the probabilities using this, which means, see, earlier we just have the PMF. We just had the PMF, and we said, let's suppose that PMF is like this, which means probability of x being maybe, let's suppose k is, let's suppose 1/6 or something like that. Okay, let's suppose this is uniform distribution, which can take from values from x can take values from 1 to, or maybe k can take values from 1 to 6. Suppose this is a uniform distribution. Then given a PMF, do I have to do anything extra to find out the probabilities? No, right? These are the probabilities only. I mean, PMF and probability were same there. But here PMF and here we do have the PDF, and PDF and probabilities are not same, which means there is some extra function which I have that was not there in the discrete, which is called PDF. This is, you can say, extra. Okay. This is extra function which says that if you want to find out the probability, then you have to integrate for this function, which means I will be having one extra function, and probabilities, if I have to find out the probability, then I have to integrate from A to B fx. Okay. Which means for valid PMF, so basically it means that probability of x being 0 to A to B. Suppose, let's suppose, for example, if I want to find out the probability of x being A to B, then what will I do? I will take A to B integration of fx. And what is this fx? Fx I will tell you intuitively later in just one or 2 minutes. But for now, understand that fx is one extra function. I mean, that was not there earlier, and this is an extra function which is not probability. But if you have to calculate the probability, maybe let's suppose x being between A and B, then you will say that probability of x being between A and B is integration of fx A to B. Okay. Suppose if I ask you the probability of x being less than or equal to B, then can you tell me that what I should be writing here? What I should be writing here and here? If this is like this, then you will say that this is from minus infinity to B, which means the minimum value of x could be anything, minus infinity, let's suppose, and then till at max it is B. Okay. Now, what does this mean? If I say that integration of minus infinity to infinity fx dx, what does this mean? It means that I'm talking about the probability of x where x can rise from minus infinity to infinity. Actually, this is the all possible values of x, and that is why this value is 1. This value has to be 1. That is like we can check whether the given PDF is valid or not. We will integrate that from minus infinity to infinity. If we are getting 1, then we can say that yes, given PDF is valid. Okay. So like x being less than or equal to infinity, you can say something like this, and then that has to be 1. Now, if you just ask me that what is the probability of x being just A, maybe you can say from A to A. If you ask me the probability from A to A, then it will be integration of A to A fx, which is just 0. Basically, a point probability in case of continuous is 0. I will tell you intuitively why it is 0, but for now understand with the formula. Okay, so we now have a new function which is called probability density function, which is basically not a probability. It is something else. It is not a probability. But if you have to calculate the probability, then we can do it at least. Okay. So why it is coming like this? 1 second. Okay. So now let's just understand this probability density function intuitively. Like, what does this mean? If this is not the probability, then what is this basically, right? Let's just see what is fx, which is called probability density function, which is called probability density function. Okay, what is fx? Let's just try to understand this intuitively. Suppose your fx looks like this. It is always a continuous function. Suppose your fx looks like this. I mean, for example, I say that your fx looks like this. Okay, suppose this is the PDF. I mean, this is some fx. Let me draw some nice graph. Maybe suppose your fx is looking like this. Okay, now tell me, can the maximum value of fx be greater than 1? Answer is yes. It could be anything. Maybe let's suppose this is 10. Since this is not a probability, this is something else. It could be anything actually. Okay, so the maximum value of this fx could be anything. I mean, maximum value of the probability is 1, that I agree, but maximum value of fx could be anything. Can the maximum value of PMF be greater than 1? Can the maximum value of PMF be greater than 1? No, because PMF is same as the probability. PMF is and the probability are same, but here the PDF and probability are not same. Can the maximum value of the PDF could be greater than 1? Then answer is yes. But the PMF maximum value cannot be greater than 1. Okay, PMF and probabilities are actually same, but PDF and probabilities are not same. But then if this is not the probability, then what is this? Let's just see. Suppose that that you are having this PDF, then tell me how to calculate the probabilities. Let's suppose this is the point 3, this is the point maybe 6. How to calculate the probability of X being between 3 and 6? You will say that you need to calculate this. Then you will say this is nothing but integration of fx from 3 to 6, right? If you just recall that integration is analogous to the area, which means you are saying the probability between being this 3 to 6 is basically this area, right? This area cannot be greater than 1. Okay, this can be 10, but this area cannot be greater than 1. If you calculate this area, it will be always less than 1 if it is a valid PDF. Okay, so if you want to calculate the probabilities between 3 and 6, you will take the integration and then you will calculate the probability, right? ठीक है, इतना समझ में आ गया कि if you want to calculate the probability, then you can do it, but fx is not the probability. ठीक है, then what is this fx? Fx is basically telling us that how much likely that you are going to get a number between 3 and 6, which means that if I just say maybe let's suppose this is 9. Let's suppose this is 9. See, this interval is 3, I mean length of 3, and this interval is also length of 3. I mean, this interval is also length of 3. What if I just ask you, what is greater? Probability of x being x between 3 to 6 is greater or 6 to 9 is greater? What do you think? From this given plot, given this PDF, what do you think? Probability of x being between 3 to 6 is greater, or probability of x being 6 to 9 is greater? 3 to 6, right? So now you have your answer. That what does this fx tell you? Fx does not tell you the probability directly, but it can tell comparatively. It can compare the probabilities basically, right? I mean, you can say that okay, most likely your x will be in this range because the PDF is higher, right? So PDF does not give you the probabilities. There is something called likelihood. It tells you the likelihood that your x will be in this range. It is having the higher probability that your x is in this range, and the lesser probability, comparatively the lesser probability that your x is in this range. That's all. It can comparatively tell you that okay, it cannot tell you the absolute value, but given the PDF, given the plot, it can comparatively tell you that okay, where is your x going to lie? Maybe in between 3 to 6, or maybe in between some other range. Then you will say between 3 to 6, which means like if I sample from this distribution, okay, like what do I mean by sample? Which means if I just follow this distribution and if I just write down some samples, then you will say, let's suppose if I follow this distribution, if I draw the samples from this distribution, draw samples, then you will say that this x that you are going to get, then most probably, I mean, there will be many numbers here. There will be many. This will be the real, I mean, real or the continuous probability distribution. But that's okay. But you can say there are many numbers here, and there are less numbers in between 6 to 9. Basically, the probability that you will get a number between 6 to 9 is actually lesser. I mean, for example, let's suppose that maybe like I don't know whether this will be a good example, but let's suppose that there is a dart. You know the dart. I mean, that is having some areas maybe. Okay, some areas maybe. Let's suppose this is. I don't remember the plot. I mean, how does it look like? But there are some areas. I think this is 100, 200 like this. 1 second. So if I throw a dart on this board, then what is the probability that it will be in some particular area? It will depend on the area basically. Okay, I mean, it will depend that if this is having the higher area, then probability that my dart will be in this area is basically higher. Now similarly, so it is actually an example of 2D, but let me take the example of 1D only. Let's suppose that you are having a 1D example where there are numbers the numbers can be from 0 to 10, but you are saying that there is most likely, if you pick some number, then most likely it is from 3 to 6. Okay, it will be in this range, 3 to 6. I mean, if you draw the samples from this distribution, then your numbers will most likely from 3 to 6. Basically, from this distribution, there is a more likely that you will be getting a number in between 3 to 6 compared to this 6 to 9, or maybe compared to some other range, which is, let's suppose, 0 to 3, right? So that's what this PDF tells you. I mean, this is enough for gate, that you just need to, at max, you need to know that what does it tell you intuitively. It just tells comparatively, that it cannot tell you the absolute value of probability, but it tells the comparative value. So let me write here, PDF directly, I mean, directly cannot, I don't know how should I write it, but I mean, directly cannot tell you, tell probability, but comparatively it can tell you. Which range is higher. Okay? I hope that is okay to everyone. So basically, just tell you comparatively. That's all you need to know about the PDF. But it does not tell you the probability. You have to be aware of this. If someone give you the PDF, then you cannot say that this is directly the probability. Is this true? Let's suppose this is let's suppose maybe 5 or 4 or something like this. Let's suppose it is 5. Then is this true that probability of being 5 is 10? Obviously no, right? I mean, this is a PDF. F of 5 is 10, I agree, but this is not the probability, right? This is not the probability. This is not the probability. Okay. This is one idea. Another thing that we should be knowing is this. See, suppose if I ask you what is the probability of being any point, probability of x being a, which means I'm actually asking you that probability of x in between a to a, then I will say it is 0. Reason being is that the area from a to a, fx is 0. Okay, mathematically this is the reason. I will tell you the intuitive reason, but at least mathematically is this clear to everyone that probability of x being a is 0? Mathematically, right? From a to a, it is 0, right? Now let's just see, if I say probability of x being probability of x in between a to b, can I write it same as probability of x is strictly lesser than a, less than or equal to b? Can I write it same as like this? Tell me. Yes, we can write. Reason being is that the probability of x being a is 0. So basically, like in fact, it is plus probability of x equal to a, but the probability of x is 0. So that's why we can write like this. Okay. So at least mathematically, this is okay to everyone. Now that is also equal to, you can say that is also equal to probability of, I mean, you can put equal anywhere, or you can just skip the equal from both the sides, or maybe you can say that equal, that is also equal to probability of maybe you can put equal at one of the side here. I mean, you can skip the equal, you can put the equal, does not matter in case of continuous case. Okay, so that is okay. Now let's just see intuitively. So it was a mathematical justification. Mathematically, you can say that this probability 0. Intuitively, actually, I mean, that's not easy to convince you, but I will try to convince you. Okay, so let's just see intuitively. Point probabilities are 0. So suppose that there is a range which is from 0 to 10. And maybe let's not worry about the exact distribution. It could be the uniform distribution. It could be some other distribution, which means maybe in between 3 to 6, there are more likely to you're getting some point or like this. That's okay. Okay. But let's not worry about the exact PDF. But if I just ask you, what is the probability of some specific point? Maybe it could be anything. Maybe 3.001278 maybe if I just ask you this, then you will say intuitively, I'm just telling you, okay, there is no mathematics I want to do it here, I just want to tell you intuitively. Then you will say, since there are infinitely possible values in between 0 to 10, and you are just asking me only one time, I mean, you're asking me for this value, So basically, like in case of discrete, let's suppose you are rolling a die again and again. Let's suppose you roll a die 100 times. Then you will write 100 because 100 is total, right? 100 is total in case of discrete. And then if I just ask you how many, what is the probability that you are getting 6? Then you will say, let's suppose out of 100 times, maybe I don't know, maybe let's suppose you say that 30 times, okay? 30 times you have gotten 6. Then if 30 times you have gotten 6, you will write 30 upon 100. And that's how you are getting the probability of x being 6. Is this okay to everyone? I mean, from the sample data, like what you will do if you want to find out the probability, you will keep on doing the experiment. Let's suppose 30 times you get 6, and out of 100 times you will write something like this. Now, since the possible values are infinity here, and if I do it again and again, probably, like what do you think? I will be getting the exact same number. Maybe 2 times, 3 times at max. If I'm very much lucky, then 3 times. Otherwise, just 1 time. Because if next time if I roll, then it is not necessary. I will be getting the same number if I just take the sample. Maybe just one digit may differ, right? I mean 639, and maybe just one digit. Maybe let's suppose this is coming out to be 3 instead of 2. One digit at least. I mean, this is very much likely that at least you are not 100% sure that every digit will be same, because it is a continuous case. There are infinitely possible values. Maybe one or two digit, maybe it may differ. Maybe in the next time, like if you do the experiment infinity times, then what is the probability that I mean, how many number of times you will be getting this number? What do you think? 2, 3, 5, and anyway, like not more than 5. Okay, I mean, you even if you do it infinity times, then in the next time maybe you will be getting maybe some 9 3. I mean, let's suppose it is 9 0, then you will be getting 9 3, or maybe some digit will change, right? So just 1 2 times, maybe 2 times, 3 times, something like this. So basically it will be a finite number here, very much finite. I'm 100% sure it will be a finite number. I'm telling you intuitively again. Okay, see, proving it mathematically is not easy. It is, I mean, like, apart from this, there is a another proof which is using a major theory and all, so which is obviously not in gate. But intuitively, if I just tell you that finite number of times you will be getting out of infinite number of times, so actually it is 0. Okay, so anyway, if you have got it, then it is okay. Otherwise also it is fine. Okay, so but now you understand that what is your pdf is not a probability. It is something else than probability. But if you want to calculate the probability, then you can calculate the probability. That's the conclusion of this complete discussion. Now let's just move to our question. Let's suppose that we want to solve this question, and here they're saying x is a continuous random variable which is having the following pdf. Now, what is the value of c here? Can you calculate the value of c? See, to be a valid PMF, what it has to do? So they are saying x is greater than or equal to 0, which means that, I mean, to be a valid PMF, first of all, it has to do this, that fx should be 1. Now, since if x is less than 0, then fx is anyway 0. So let me just write it 0 to infinity. Okay, because if x is less than 0, then anyway, like fx is 0. So fx means c into e power minus x is 1. Okay. Now can you just integrate it, and then can you calculate the value of c? What is the value of c that you are getting? See, first of all, are you okay with this? That why I'm writing from 0 to infinity? See, it should be from minus infinity to infinity. Okay, fx, and then like it should be 1. Then I said this minus infinity to infinity is same as, like, I can write this minus infinity to infinity fx is same as basically minus infinity to 0 and then 0 to infinity. But this minus infinity to 0 is given out to be 0 only, right? They are saying that if x is less than 0, then this is 0. So that is why this term is 0. So that's why I'm just writing it from 0 to infinity. So I'm saying that from 0 to infinity, it should be 0. It should be 1. From 0 to infinity, fx should be 1, which is basically from 0 to infinity. 0 to infinity, c into e power minus x, it should be 1. Then c you can take outside, and then integration of e power x is just, I think, e power x, right? If I'm not wrong. So it will be e power minus x because it is minus. So e power minus x minus. because you need to divide by -1 also. So it is this, and then you can say it is minus of c, minus is outside, you can say it is minus c, and then from 0 to infinity. If you put the values from 0 to infinity, which means if you put the infinity, e power minus infinity, just like 1 upon e power infinity, which is 0, minus 1 upon e power 0, minus c should be 1. So this is 0, 0 minus 1 into minus c is 1, and then c is coming out to be 1. Is this correct? Just verify it quickly. Right? C is coming out to 1. So final answer is, like, if they are asking that what is the value of c, then you can say c is 1. Okay? So the value of c is 1. Now they're asking what is the probability that x being between 1 to 3, which means they're asking that what is the probability that x being between 1 to 3, then you will say it is same as the integration of 1 to 3 fx dx, and fx is e power minus x, c into e power minus x, basically e power minus x, and then it is from 1 to 3 dx. Okay, now you can calculate it. It should be e power minus of e power x from 1 to 3, and then it will be minus of e power minus 3, minus and minus will be just plus, and then e power minus 1. So anyway, this will come out to be your probability. Okay, let's not calculate the final answer because it's not required, but you should be convinced with the process, like how to calculate the probabilities in case of if the PDF is given. I mean, mostly they will ask you that much question in the continuous. They will not ask you related to the type of continuous variable. I think they've asked just 1 or 2 questions from the continuous random variable till now. If not 2, then maybe 3. 3 questions they have asked till now, which means in the 36 year or in the 40 years, they have just asked the three questions in this continuous random variable, because it involves with the higher mathematics and integration and all. So generally they avoid to ask. Okay, but still, since it is in our syllabus, we should be looking at it. Okay, so I will tell you intuitively, mathematically, whatever is required for gate, I will tell you all the things. Now let's just see this. Okay, C, oh yeah, C is coming out to be, to find C, we can use this property. So this is actually equal to 1, and the C is coming out to be 1. We must have C as 1, and then this is the probability of 1 to 3. Okay, these are the answers. Now let's solve this question. They're saying a probability density function on the interval a to 1 is given by 1 upon x square. Okay, which means fx, PDF they have given to be 1 upon x square if x is between a to 1. Okay, which means if x is less than or equal to a to 1, and outside this interval the values of the function is 0, otherwise the value is 0. What is the value of a? Can you do it? So I think it should be integration of a to 1 fx is, I mean, this is the only place where it is non-zero. So you just need to write the non-zero things. Okay, otherwise you do not need to write any other thing. So this is basically 1 upon x square into dx is equal to 1 to be a valid PMF, right? Now I think you can integrate it. What is the integration of 1 upon x square? Anyone quickly? I mean, if you know this is okay. Otherwise also this is okay, because I have not taken the integration class, but that's okay. It is minus 1 upon x, right? So you can say it is minus 1 upon x. A to 1 is 1, and then from here you can find out the value of a. What is the value of a you will be getting from here? It will be minus 1 upon x. A to 1 means you will write the 1 minus 1 upon 1 minus, and minus will be plus 1 upon a equal to 1. It will be 1 upon a equal to 2, and then a will be 2. Sorry, a will be 1 by 2. Right? So that's how you can calculate the essay. So a is coming out to be 1 by 2, which is 0.5. So it was an NAT question, I think. So that's why the value of a you can write 0.5. Easy question, right? At max they will ask these things. They've asked just one to different type of things in the continuous random variable. We will see all the things, but generally they just ask these things only in the continuous random variable. You should be able to apply the integration of fx is 1. That's all. Okay. So let's just compare between discrete and continuous random variable. Then we will see the different type of continuous random variables. And the first continuous random variable will see uniform, then normal, and then exponential. So let's just see the difference between discrete and continuous random variable. So discrete random variable takes the values which are basically countable values. Let's suppose the discrete values, which are, let's suppose the 1 to infinite, like something like this. It can take any values in some range, which means it can take infinitely possible values, and that is in fact uncountable. Okay. So it can take infinitely possible values, but it will be taking discrete values here. Now here I used to have the probability mass function, but here I will be having the probability density function. Here, if you remember, then we were having CDF. Here also the name is same. See, the only difference is between PMF and PDF, but the CDF is same. Which means here earlier I used to say probability of x equal less than equal to k is a CDF, which was something like this. If you remember, there was CDF, some definition of some function, and then the same story here. You can have the similar CDF here, but it will be obviously like you need to calculate it separately using some other formula, which is minus infinity to k this fxdx. Earlier it was all the probabilities that are giving out to be your x less than equal to k. So you can calculate the CDF in both the cases. Earlier, the expectation was something like this. Here, the expectation will be minus infinity to infinity x fx. Okay. The formulas are changing. That's all. And earlier, the variance was this. Here, the variance is this. I mean, variance formula is same, but the expectation you need to calculate differently. The expectation of x square will be minus infinity to infinity x square fx. Okay. So you can look at this slide later also. I mean, you at the time of revision, that what is the difference between discrete and continuous. There is no difference apart from this PDF and PMF. And then obviously the formulas of the expectation, these things also vary, because the whole calculation of the probability is even varying. Let's just see the first distribution, the first continuous distribution, which is the uniform distribution.